Hello student, this is my first lecture on real analysis for third sem honors as well as GE students. I Miss RANJANA Dutta from the Department of Mathematics, the Graduate School College for Women. Here, today we will start the limits, definition of limit. Let the number a is said to be the limit of fx at x equal to a if for any arbitrary chosen positive number zeta, however small, there exists a corresponding number delta which is greater than 0 such that modulus of fx minus a is less than equal to zeta, and the values x minus a modulus lies between 0 and delta. The meaning of modulus of x minus a less than delta modulus. So modulus of x minus a can be written as x minus a or a minus x. If x minus a if x is greater than a, and a minus x if x is less than a. So when modulus of x minus a less than delta, that means x minus a less than delta if x is greater than a, which can be written as x is less than a plus delta, and x minus a less than delta if a minus x is less than delta if x is less than a, which can be written as a minus delta is less than x. So x modulus of x minus a is less than delta can be written as x lies between a minus delta to a plus delta. So a minus delta open interval a minus delta comma a plus delta. Also x minus a is greater than 0. This implies x is not equal to a. Hence, thus x minus a modulus lies between 0 and delta, define that the neighborhood of the open interval a minus delta and a plus delta. Right and left hand limits. If x approaches if a from the right, that is from a larger value of x, then a the limit of fx as defined above is called the right hand limit of fx, and we can write it as limit x tends to a plus 0 is fx or f a plus 0. Similarly, f a plus 0 limit h tends to 0 f a plus h, and limit x tends to a minus 0 fx or f a minus 0, and the third one f a minus 0 is equal to limit h tends to 0 f a minus h. If both the limits, that is the right hand limit and the left hand limit of fx as x tends to a is exist and are equal in value, then the limit of fx as x equal to a exists, and the common value of the limit is known as the limit. If both the left hand limit and the right hand limit are of equal value, then we say that the limit of fx as a x equal to a does not, if they are not equal, then we can say x tends to a does not exist. If either or both the of these limits do not exist, then the limit of fx as x tends to a does not exist. That is, if the left hand limit is equal to right hand limit, then the limit exists and the value of limit is called the limit of fx at x equal to a. If the limits exist but they are not equal, then the limit does not exist. And if they do not exist, one of them also not exist, then we say that the limit does not exist. Now we shall prove some theorem on limit. The limit of a sum of two function is equal to the sum of their limit. Let x tends to a fx is equal to capital A and limit x tends to a phi x equal to capital B. We have to prove that limit x tends to a modulus of fx plus phi x is equal to limit of x tends to a fx plus limit of x tends to a phi x. Let limit of x tends to a fx is equal to a. Therefore, by definition, fx minus a less than equal to zeta, where x minus a modulus is less than delta 1. Similarly, phi x minus b modulus is less than equal to zeta by 2, where x minus a modulus is less than delta 2. If delta is the minimum of delta 1 and delta 2, we can say that x minus a less than delta. This implies fx minus a less than zeta by 2 and x minus a less than delta implies that phi x minus b less than zeta 2. Then fx plus phi x minus a minus b can be written as fx minus a plus phi x minus b. So fx minus a, if we decompose the modulus, we can write it as less than equal to fx minus a modulus plus phi x minus b modulus, which is less than equal to zeta by 2 plus zeta by 2, that is zeta, where modulus of x minus a is equal to delta. Hence, limit x minus a phi x fx plus 5x is equal to a plus b, which is equal to limit of x tends to a fx plus limit of x tends to a phi s. Now, the difference, similarly, we can show that the difference of two functions, limit x tends to a fx minus phi x is equal to limit x tends to a fx minus limit x tends to a phi x. So, students, today this much only. Thank you.